So in this lecture, we're going to talk about one of the very important technique, that is what we call the partial fraction method. So partial fraction method, partial fractions method, partial fractions method. So so what we do is we have a rational function to start with, rational function. What we can do, we can decompose that into so decompose that into linear and quadratic denominators, quadratic denominators. So that's what we do. So we have a rational function. We're going to decompose this with fractions with linear and quadratic denominators. And after we do this, we're going to use some results, like for example two major results. So what are those major results? We know that the integral of 1 over x dx is ln x plus c, and we also know that similarly when we have x with a constant, and then we can show that using the 4 equations, or but just by substitution technique. If you have x plus a, this simply becomes ln x plus a plus c, and then these are for linear factors. And then if you have a constant in front, and you know what to do, you can multiply and divide, and then so for example we can write if we have 1 over, let's say ax plus b in general dx. So what we can do is we can write this one as 1 over a, and then ax plus b dx. Then according to 4 functions, so this is simply 1 over a natural log ax plus b. So this is what happened to the linear case. If you have a linear denominator, you can always write it like that. And the other one is if you have a quadratic denominator. Quadratic means it's basically going to be x squared plus a squared situation. So if this is the case, then we know that this is simply 1 over a tan inverse x over a plus c. So we know these 2 situations. So those are the kind of major results that we need for this section, because most of the things, most of the problems that we're gonna handle bring boils down to one of those situations. And then how the method works. So it has several steps. So the method, so we're gonna look at, so the first thing that we do is we're gonna check whether it is a proper fraction or a improper fraction. Improper fraction. So if it is a improper fraction, what we do, we're gonna divide. We're gonna do the division. We're gonna divide, and then we're gonna get that to the proper fraction. What the proper fraction means? So the proper fraction means, so we have proper fraction, proper fraction. So proper fraction means the degree of the numerator has to be smaller than the degree of the denominator. That's what we call a proper fraction. So if the degree of the numerator is smaller than the degree of the denominator, because of proper fraction, if it is not the case, what we do, we're gonna divide them. We're gonna divide and then bring it to the proper fraction. So that's the first step we do. And the second step is what we call write the form. Write the form. So we're gonna call, like, there's a special format that we want to start with. So that's the second step. We can write the form. So we can discuss like several examples to see what we mean by that. So write the form. That's the second step. And then after you write the form, you're gonna notice that there are some coefficients. So what we're gonna do is find the coefficients. Find the unknown. Actually, find the unknown coefficients. Find the coefficient. Using what we normally do is we can use the hybrid method. So the book doesn't use that, but we're gonna use hybrid method because that's the fastest method. So find the coefficient using hybrid method. What's the hybrid method? The first we can use the substitution subs, and then the second we're gonna use the equating coefficient technique. Equating coefficient. So equating coefficient. So this is how the method works. So we're gonna see whether it's a proper fraction or improper fraction. If it's improper fraction, we divide and bring it to a proper fraction. And after we get the proper fraction, we're gonna start with the proper fraction. That's gonna be a rational function with a degree of the numerator less than the degree of the denominator. So we can write the form, and after you write the form, you're gonna see that there are a lot of unknown functions. And then what we're gonna do, we're gonna unknown coefficients. We're gonna use the hybrid method to find the unknown. First, we're gonna use the substitutions. We can substitute some numbers, and then after we're done with that, we can use the equating coefficients to find the rest of the coefficients. Okay, so that's how the technique works. So let's look at the several examples. So as the first example, let's look at this problem. Actually, before we start problems, I would like to write forms. So let's write several forms, and then we can look at it. Then things gonna be much easier. So write forms. Okay, so writing forms. So let's look at this example. So let's say if you have a expression like this. So let's say we have 2x plus 1 over x minus 2 and then x plus 1. So you can see that there are two linear factors. So what we can do, if you see two linear factors, we can write the corresponding form like this. We know that the one denominator has to be x minus 2, the other denominator has to be x plus 1, because those are linear factors. The question is, what's going to happen to the numerator? Numerator is always 1 degree less than the degree of the denominator. So that means the bottom is a degree 1 polynomial. So that means the numerator has to be degree 0 polynomial. Degree 0 polynomial means it is a constant. So we're going to put a here. So it's a. The same thing b. So that is what we call the form. So this is what we call the form. So that's the form. And then also the degree of the numerator is less than the degree of the denominator. And then in a problem we can discuss how to find them. Okay. So but here we just write the forms. So let's look at another example, another problem. So how about this one? So let's say we have x squared plus x minus 5 over x minus 1, x plus 2, x minus 3. Okay, and then also we use the identity sign. It's not equal, they are identically equal. Identically equal means they are exactly the same on the two sides. That's what identically equal means. Here we're going to see three linear factors, so we need three terms. So it's a over x minus 1, and then b over x plus 2, and then c over x minus 3, because there are 3 linear factors, so it's a b, c. So the goal is to find a, b, c, and then we can discuss that in the next one. It's very easy. And then number 3, so this is what happens if you have 1 linear factor and 2 linear factors. So there are 3 different factors. And then the third one, how about we see a repeated factor, like for example 3x plus 1 over 2x plus 1 times x minus 1 squared. So the only difference is here the repeated factor. So you're going to see the repeated factor, a repeat. So when you have a repeated factor, we're going to follow a different technique. What's going to happen? So we can write the first one. The first one is a linear factor, so it's a over 2x plus 1. There's no problem with that. And the second one, what we're going to do, if you see a repeated factor, we're going to write all the factors is starting in the lowest power. So lowest power is 1. So that means we're going to write x minus 1. So it has to be b. That's the next right. And then the next factor is x minus 1 square. But you can see that this is square. That means a degree 2. So in theory, if it is degree 2, the numerator has to be degree 1 less. That means degree 1. Degree 1 means a degree 1 polynomial. It's a linear factor. But we don't do that. We don't want to do that. So we can show that even in this case, even though the degree of the denominator, so the degree equal to, even the degree of the denominator is 2, we don't follow the general pattern. What's the general pattern? Degree of the denominator, degree of the numerator less than the degree of the 1 less than the degree of the denominator. But when you have repeated factors, you can simply follow the pattern of the lowest one. What's the lowest one means? That's the lowest one. So the pattern of the lowest one is a degree 0 degree 0 term on the numerator. So we're gonna follow the same method. So when you have repeated factors, we're gonna follow the same one. That means it is just a constant term. This only works when we have repeated factors. So it's a degree 0, because this is degree 0. So you're gonna follow the pattern of the smallest one. It is for repeated factors. So that means so let's write one more of the same type. So let's say number 4, 2 x minus 1. So let's write 2x plus 1, and then x minus 1 cube. So what's going to happen here is a over 2x plus 1, and then b over x minus 1, and then c over x minus 1 squared, and then the d over x minus 1 cube. So you can see everything follows the pattern of the smallest one. Okay, and then let's go to number 5. How about you're gonna see a irreducible for example star here is the same thing, irreducible factor like that. So we're gonna see 2x squared minus 3x plus 5, let's say plus 3 maybe, and then we have x plus 1, x squared plus 4. So in this case, so this is like this situation is different. So you can see the first term is okay, so it is a over x plus 1. But what about the second term? Second term has x squared plus 4, and you know that you cannot reduce this any further. You can factor this, okay? Cannot factor. So cannot factor. That's what we call irreducible. If it is irreducible, there's nothing you can do. So what we can do, we can write the numerator with the degree 1 less than the degree of the denominator. So it's a degree 2, So this is degree 2. So in this case this is degree 1, degree 1. Okay, so degree 1, so that means this one has to be degree 1. That means it's bx plus c. So we need to find b and c in this case. So that's a special situation. So if you have a quadratic is irreducible, then what we can do is degree 1 less than, so that means degree 2, that the numerator has to be degree 1. So those are all the types that we have. So and then as the last one, how about like, you know, if we have something like this, let's say you have x plus 7 over x cube minus 4x. What we do is, if you get something like that, we're gonna factor this completely. That's the first step, factor completely, and then start writing terms. So so if you factor this completely, what do you get? You know, x plus 7 over you can take x out, and then you're gonna get x squared minus 4, and then you can see that you can factor this again. So you're gonna get x x minus 2 and x plus 2. Now we can start writing the terms. So it is a over x, and then b over x minus 2, and then c over x plus 2. So this is the form for this one. So you can see that it's not that difficult. So many repeats, it's going to follow the pattern of the smallest one. And if you have a quadratic term, we need to write degree 1 polynomial. So as in 5, you have bx plus c in the situation. So now it's very clear. So now what we're going to do, we're going to follow these patterns in the next few problems. Okay, so yeah, so I'm going to give you a few problems that you can write. So I'm going to give you this as an exercise. So why don't you try these problems? So so exercise, write the form, So let's say the first one is let's go with x plus 5 over x minus 1 x plus 1, and number 2, let's write 2x minus 3 over x3 minus x squared minus 2x, and number 3, you can do x plus 1 over x minus 2, and then x squared plus 4, and number 4, you can write 2x squared minus x plus 1, x minus 2, and then x plus 1 squared, and number 5, why don't you try something like this, x to the 6th power x to the 5 minus 16x. So you might need to do a lone division here, and also number 6, let's do x3 minus x over x plus 2. Okay, so so you can try these problems as practice, and try to write the forms of this. Okay, now let's try to go to real problems. So what we can do, we can handle problems like this. So the problem is, I'm going to call example number 1. Okay, so let's say integrate integrate. The problem is x squared plus 2x minus 1 divided by x plus 1 dx. So once you look at this problem, you can see the first thing you notice is it is a rational function. So it is a rational function. And you notice that the degree of the numerator is greater than or equal to the degree of the denominator. That means we had to do something because it is a improper fraction. So it's improper fraction. That means we need to do the division. Okay, so we divide. So what we're going to do, we're going to do the division here. So I'm going to use the log division. So we're going to have x squared plus 2x minus 1. And if you see some terms are missing, you have to add zeros for that. And then we're going to divide by x plus 1. So we're going to look at always the first coefficient. So the first term of each, so x squared, that means x is missing. So when you multiply by x, you get x squared plus x. Now what we do, we're going to subtract them. Once you subtract them, you're going to get x, and then you're going to so we subtract, and then we're going to pull the negatives, this term here, so it become negative 1 now. Now you can see that 1 is the term here, so it is plus 1. Because when you look at x and x squared, so it's a 1. So we're going to multiply by 1, so it is x plus 1, and then again we're going to subtract. When you subtract, you're going to get negative 2, and then you can see that is degree, the degree of that term is less than the degree of the this one. The degree of this is degree 0, this is degree 1, so you're gonna stop. Okay, so we have the terms that we need. Now we can write the fraction like this. So what we get is this. So we're gonna get that when you divide x squared plus 2x minus 1 by x plus 1, you get the quotient as x plus 1. That's the quotient, and then you get a remainder is negative 2, so you have to divide that one by the divisor. Divisor is x plus 1. So this is how we write it. So so the quotient and the remainder. So that's the quotient, and this is the remainder. That's the remainder. So now we can finish the rest of the problem. So what we can do, so we can integrate x squared plus 2x minus 1 over x plus 1 dx, and then what's going to happen, but we know that this is exactly equal to x plus 1 minus 2 over x plus 1. Now we're going to integrate term by term. If you integrate the first one, you're going to get x squared over 2. If you integrate the second one, you're going to get x minus, this is a log function, so you're going to get 2 natural log x plus 1 plus c. So that is the answer. So we can do, so I hope it's very clear. So after the division, you can integrate basically term by term. So let's do another problem, like a little kind of similar type. So how about this one? So you can integrate x plus 3 over x plus 1 dx. So I'm gonna show you a trick here. So you can again do the log division as we did before. So so if we do the log division, what do you get? So it is x plus 3 x plus 1, so you have a 1, so you're going to get x plus 1, and when you subtract you get 2, so you're done. So that means the quotient is 1, the remainder is 2. So also, but what we can do, we can use some trick here, some algebra. So what we can do, we can create the denominator in the numerator. So that means we can write the numerator like x plus 1 plus 2 divided by x plus 1. So we write it like that. Now what we can do, if we divide 1 by 1, if you divide from the first one, you're going to get 1. From the second one, you're going to get 2 over x plus 1. So that's exactly the same thing, but sometimes we can do this kind of tricks to make the calculation fast. Now we can integrate term by term. So if you integrate term by term, from the first one you get x, from the second one you get 2 ln x plus 1. So that's much faster. So you can avoid the long division sometimes. Good. So this is what we do. Like, if you see a larger denominator, a larger numerator, if the degree of the numerator is larger than degree of the denominator, we divide first, and then we can integrate term by term. So let's see what's going to happen if we have two factors. So the next one, let's do this one. So next example, integrate 5x minus 3 over x plus 1 x minus 3 dx. So what we can do, we're going to see that this is a proper fraction because the degree of the numerator is smaller than the degree of the denominator. That means a proper. So that means everything works fine here. So we're gonna use the technique. So what we do, we can write 5x minus 3 over x plus 1 x minus 3 identical to a over x plus 1 plus b over x minus 3. And then what we can do, so there's a form, so we write the form. So the next step, so now we're gonna discuss how to how the method works. What we can do, we're gonna multiply both sides by the common denominator term. So we're gonna multiply both sides by this term. We can multiply by this term both sides. So that means if you do that, so what do you get? So you're gonna multiply both sides. So you're gonna do x plus 1, x minus 3, 5x minus 3 over x plus 1, x minus 3, and then here also we have a x plus 1. Again you multiply this term as well, the second term, and do the same thing with the other term as well. Now see what's going to happen. So what we did, we multiply both sides by the common denominator. We multiply both sides by the common denominator. Now you can see there is a nice cancellation going on. Here this term cancels with that term. On this side, this term cancels with that. Here this one cancels with that. So after the cancellation, what do you get? You get 5x minus 3 identical a x minus 3 plus b x plus 1. That's what you get. After the cancellation, you're going to get that. Now what we're going to do, we going to use what we call the hybrid method. We're going to first use substitution. We're going to substitute because this is identity. When you have an identity, identity means it's true for any value. This is an identity. identity. So like true for any value of x. So you can plug in any x value, it is true. That's what it means. You can plug in any value, but there are some special values that makes the calculation faster. So the goal is, let's say you want to find a. If you want to find a, you try to make the coefficient of b 0. If you want to find a, you try to make the coefficient of b 0. To do that, if you plug in x equal negative 1, if you plug in x equal negative 1, x plus 1 becomes 0. So then that term is going to go away, so you're going to get a. Similarly, if you want to find b, you try to make the coefficient of a 0. That means you plug in x equal 3. So if you plug in x equal 3, the coefficient of a becomes 0, so you get b. So that is the trick. So you're gonna, so you know that this is true for any value, but there are special values that makes this calculation much faster. So that's exactly what we do. We're gonna substitute. So we're gonna say so substitute x equal, let's say you want to find a, so that means you want to make the other term 0. That means you're going to plug x equal negative 1. And once you do that, let's see what's going to happen. It is 5 times negative 1 negative 3 equal, now we write equal a negative 1 negative 3 plus b negative 1 plus 1. So you can see that that term is 0. That term is 0 means you do not get that term anymore. So that means this side simply becomes negative 8 equal 8 times negative 4. It says that a equal 2. So we do the same trick. So we can substitute x equal, now to find b, we can substitute x equal 3. We find x equal 3, it is 5, 3 minus 3 equal 8 times 0, we know that, plus b, we plug in 3, so it is 3 plus 1. 3 plus 1. So this is going to make 12 equal b times 4. So this is going to give you b equal 3. So we find a and b. So after we find a and b, now what we're going to do, we're going to substitute that into the form. So that means, so therefore, so your form 5x minus 3 over x plus 1 x minus 3 now equals to, so you can just say equal now, equals to a, how much? 2. So it's 2 over x plus 1, and then plus b is 3, so 3 over x minus 3. Okay, so we find the two unknown. So we use the substitution method. So we substitute special values so that those numbers comes really fast. Now what we can do, we're going to finish the integral now. So we can go to the integral. So that means in the integral it is 5x minus 3 over x plus 1 x minus 3 dx. Now what we can do, we can integrate term by term. So the first term was 2 over x plus 1 dx, plus the second term was 3 over x minus 3 dx. And then what's going to happen, so this is 2 ln x plus 1 plus 3 ln x minus 3 using the 4 formulas. So so that's the answer. So that's how we do the integral. You can see that that's the technique is very simple, very simple. But what you need to do, you need to understand how this argument works. So you write the form first, and then we multiply by the common denominator and get the identity. After you get the identity, we're going to substitute special values so that you're gonna get those numbers out fast. So what we normally do is we try to make the other term 0. We try to make the other term 0, and that way you can find what you need. Okay, so let's try to do another example. How about we have 3 unknown, 3 linear factors. So integrate x squared plus 4x plus 1 over x minus 1, x plus 1, and x plus 3 dx, something like that. So its argument is very clear. So what do we write the form? So the form is x squared plus 4x plus 1 over x minus 1, x plus 1, x plus 3 identical to a over x minus 1, b over x plus 1, c over x plus 3. It's very clear. These are linear factors, so we write a, b, c. Now we're going to multiply by the common denominator, and after you multiply by the common denominator, you're going to get x squared plus 4x plus 1 identically equals to a times. When you multiply, what's going to happen here? What's going to happen? The x minus 1 factor get cancels and you get the other 2. So when you multiply, you get the other 2. So that means you're going to get x plus 1 and x plus 3. And then for b, again, you x plus 1 get cancelled, you get the other 2. And then for c, x plus 3 get cancelled, you get x minus 1 and x plus 1. Okay, so this is very clear. You always cancel the denominator term and you get the other terms. Now the substitution step. So what we can do, so let's say you want to find a. So if you want to find a, see what is common in the other 2. So for example, if you want to find a, you can see this and that are common. So that means if you try to make those 2 terms 0, you can find a. You try to make the common term 0. That's the common term. So right, that's the common term. So we try to make the common term 0. So that means you need to plug in x equal. What are you going to plug in? You're going to plug in x equal 1 to make that 0. That's exactly what we do. So you can plug in x equal 1. So if you plug in x equal 1, you're going to get 1 plus 4 plus 1 here. You get a times, if you plug in 1, you get 2 and 4 plus 0 and a 0. So this is going to give you a. How much you get a? So you have 6 on this side, you have 8 on the other side. So you're going to get 6 over 8. 6 over 8 means 3 over 4. So you already found a. Use the same trick. So let's say we want to find b. If you want to find b, look at the other 2 terms. You can see that x plus 1 is common. X plus 1 is common. So if x plus 1 is common, what we can do, we find x equal negative 1. So you can substitute x equal negative 1. Applying x equal negative 1, what are you going to get? You're going to get 1 minus 4 plus 1. You plug in negative 1, you get a 0. And here b, you get negative 2 and a 2 and a 0. So this says that b equal. So you're going to get negative 2 on this side, and you get negative 4 on that side. So you're going to get b equal 1/2. Now let's say you want to find c. If you want to find c, look at the first 2 terms. In the first 2 terms, x plus 3 is common. So you're going to plug in x equal negative 3. Okay, because to make the term 0. So if you do that, if you plug in negative 3, you're going to get 9 minus 12 plus 1, and then you get a 0, and you get a 0, and then you're going to apply -3, so the c times -3 means -4, -3 means -2. It's going to give you c equal -1/4. Okay, so we find all the terms. Now we can finish the integral. So let's see how the rest of the work works. So we're gonna have integral. So it is x squared plus 4x plus 1 over x minus 1, x plus 1, x plus 3 dx equal so it is a is 3/4 over x minus 1 dx plus b is 1/2 over x plus 1 dx, and then minus 1/4 over x plus 3 dx. These are very easy to integrate, so you're going to get 3/4 ln x minus 1 plus 1/2 ln x plus 1 with the absolute sign, okay, -1/4 ln x plus 3 plus c. If we sometimes, you know, we can even combine them because 1/2 power is square root, so you can bring the square root power inside. 3/4 you can bring as a power, -1/4 you can bring as a power, and then you can, because those three terms you can add them because addition, so that means you're going to multiply inside. So that we can do sometime. You can, like, if you get like good numbers, you know, integers, positive or negative, it doesn't matter, negative means divide, we're going to combine, but otherwise we're going to leave it like that. Okay, but you can see that even with three terms it doesn't take much time, so it's going to be like a simple problem. Okay, so we talk about two types. Actually at the beginning we talk about linear types, and then we talk about what happens if you have two linear factors, and then we talk about what happens if you have three linear factors. Now let's do a problem with a repeated factor, repeated one. So what happens if we have a repeated term? So let's do that now. So how about this problem? So we're gonna do 6x plus 7 over x plus 2 squared dx, and we talk about before what's going to happen if you have a repeated factor. So what are the repeated factors? So in this case what we're going to do is we can write this one as 6x plus 7 over x plus 2 squared, so identical to a over x plus 2, and we follow the pattern of the smallest one, so we can write all the factors until the largest power here. So but we follow the format of the smallest one, that means we just write a constant here. We don't want to write bx plus c in this case. You can, but just a waste of time. And then what we do, we're going to multiply by the denominator, so you're going to multiply by x plus 2 squared both sides, and if you do that you end up getting 6x plus 7 equal a x plus 2 plus b. That's what they get. Now we're gonna substitute. So let's try to in this case it's easy to find b first, so we're gonna substitute x equal -2, so we're gonna substitute x equal -2. So if we do that, you're gonna get 6 -2 plus 7 equal a times 0 plus b is going to give you b equal, what do you get for b? -5. Good. Now you can see that this identity, you can pretty much substitute anything you want. So the most of the time the easiest number that you can substitute is 0, so we can substitute 0. So you can substitute x equal 0. If you plug in x equal 0, you get 7 equal a times 2 plus b is -5. So and then you can find a. So how much you get for a? So you can get 2a, so you got 12, so 12 equal 2a, that means a equal 6. Okay, now we find both. So what we can do is we can plug in back. So we have 6x plus 7 over x plus 2 squared dx equal a is 6, so the 6 over x plus 2 dx plus -5 over x plus 2 squared dx. So this one is, the first one is easy, so it is 6 ln x plus 2, and the second one you can use the power rule, you can bring it to the top, so it's going to be -2, and then we can use the 4 formulas again here, because the derivative of this one is, derivative of x plus 2 is just 1, so it's just 1, so you can pull the -5 out. So that means if you use that, we just use the power rule, so that means it's being x plus 2 to the -2, that means x plus 2 to the -1 over -1 plus c. Just use the power rule or the 4 formulas. Okay, so this is simply coming from 4 formulas, and then you can write the final answer now. So it's gonna be 6 ln x plus 2, so we can solve well. Okay, so it's very important. So it is plus, so you can say 5 over x plus 2 plus c. So that's the final answer. So you can see that as a problem, that's not difficult, but only thing is you need to remember is the how you to write the form. Okay, so the form has a special format. In the exam, so I'm going to give you a question just to write the forms. Okay, so you only write the form, you are not going to find ABC, but write the forms. So that's important. Okay, and also in this step you can also use a substitution method if you want to solve this problem, but the 4 formulas are much faster. Okay, so this is what happens if you have repeated factors. So I'm going to give you an exercise you can try. So how about this one? So this is a extracted problem. So so the problem is integrate x plus 3 over x cube minus 4x dx. Okay, so I'm going to write the first term and write the rest of the terms. So it's a -3/4 ln x, and what are the other terms? Okay, so this is an extra case, so problem, so you can submit this by email. Good. So now let's see what's gonna happen. So we already did 3-factor term, so this is a 3-factor situation, and completely factor first and then start writing terms. So the complete factoring is very, very important. Okay, so you do complete factor and then start writing the forms after completing the after factoring completely. Good. So good. So let's do a problem, maybe with 3 repeating. It's the same thing, but let's just do one more problem just to see how things going on. So I'm going to do like 2 more examples. So the next one is, how about we have 6x plus 7 over x plus 2 cube. Argument is very similar. We can write the form first. So it is 6x plus 7 over x plus 2 cube, which is identically equals to, we start with the smallest one always, so x plus 2, and everything follow the same pattern. So it is a b over x plus 2 squared, and then c over x plus 2 cube. That's what you get. That's the form. Everything follows the pattern of the smallest one. Now we're gonna multiply by x plus 2 cube both sides. After you do that, you're gonna get 6x plus 7. Identical a, you have x plus 2, because of cube, so that means there's only one term cancel, you get a square here, and then b x plus 2, and then c, you don't get any terms there. Good. So now what we can do, we can start substituting. So we can substitute x equal -2. Once you substitute x equal -2, you're gonna get -5 equal, you're gonna get 0 plus c. This says that c equal -5. But unfortunately, you can see that there are no number that you can substitute and get the other values fast. That doesn't work anymore. So what we're trying to do now, we're gonna start equating coefficients. So we're gonna use the equating coefficient method now. So that's a hybrid. So we're gonna do the substitution first. We're gonna do the substitution as much as we can first, and then we're gonna start the coefficient. So we're gonna go with the coefficient, and also when you do the coefficient, start with the largest coefficient. Okay, start with the largest coefficient. We do subs first, and then start with largest coefficient. Start with largest coefficient. So that means in this case we can start with the coefficient of what's the largest coefficient we can have, largest term. Yeah, we say largest, not the largest coefficient, largest term. Okay, so like largest, yes, that's not exactly correct, largest degree. So so what's the largest degree? X squared. So when you start with x squared term. Okay, so term with the largest power, basically term with the largest power. So what we can do, we can equate the coefficient on the two sides. You can see that there is no x squared coefficient on the left side, so the coefficient has to be 0. That's why you don't see it. On the right side, you can see that in the first term you have a x plus 2 squared. That means you get x squared term, so the coefficient going to be simply a. This says that a equal 0. Not always. Okay, and then what we can do, we're gonna go with the we can now we can also like substitute like any other value if you want. So that's another way to do it. Or we can even substitute. So what I can do, I'm gonna go with substitution and substitute x equal 0. Okay, when x equals 0, you're gonna get 7 equal this is a equals 0, so you don't get anything. And here b, if you plug in x equals 0, you're gonna get 2, and this is -5. So this is gonna say what is b, so b equal you're gonna get 6. Okay, so we find ABC. Now we're gonna go back to the problem and finish it. So we have 6x plus 7 over x plus 2 cube dx. So this is so a is gone, so we have two terms, so it's a 6 over x plus 2 square dx minus actually plus no, it is minus, c is minus, so it's yeah, that's fine. So it is minus 5 over x plus 2 cube dx. And then what's gonna happen here is we have 6 x plus 2 negative 2 dx, and then negative 5 x plus 2 negative 3 dx, and then we can just use the power rule. So if you use the power rule, you're gonna get 6 x plus 2 negative 1 or negative 1 by the 4 formulas, and then minus 5 x plus 2 add 1 divided by that plus, so this is coming from 4 formulas, and then you can write the final answer with negative 6 over x plus 2 plus put 5 here, we put 2 there, x plus 2 squared plus c. So that is the that's integral. So here we use the hybrid method. We're going to use the coefficient substitute, so it's a hybrid. We're going to use the substitution first, and then we can use the coefficient. So this is much faster than writing equations. So let's do one last problem before we finish the section. So this is the last one. How about you're going to see a quadratic term. So you're going to see negative 2x plus 4 over x squared plus 1, and then x minus 1 squared dx, something like that. So you're going to see a repeating and also quadratic terms. So let's try the form first. So the form is negative 2x plus 4 over x squared plus 1 x minus 1 squared. So this is identical to we can write the repeated terms first. So we're going to say a over x minus 1 plus b over x minus 1 squared, and here we have x squared plus 1. So but this is like special term, this is not a repeated term, so we have to follow the regular technique. That means degree of the numerator has to be degree 1 less than. That means you can write this one as cx plus d. So that means 4 unknown situations. There are 4 unknown, but that's the correct form. Okay, so let's try to write the 4 unknown. So we can do we're gonna multiply both sides by the common denominator. So that's the common denominator, so we're gonna multiply by that. So if you do that, you're gonna get negative 2x plus 4 equal a times you're gonna get one term and also one quadratic, plus b x minus 1 squared will cancel, you only get x squared plus 1, and then here you have cx plus d, and then we have x minus 1 squared. Okay, x minus 1 squared. Perfect. Now always when we have this one, we can use the substitution method first to find as much as we can, and then we start finding others. So So we can substitute, you can see we can find b first because there's a common term x minus 1. So we're going to substitute x equal 1. If you plug in x equal 1, you're going to get on this side 2 equal, if you plug in x equal 1, you get 2 equal 0 plus b times 2 plus 0. So this says that b equal 1. So we find b first. Now what we're trying to do is we can start always with the largest power and then start writing the coefficient. So we go with the largest coefficient. So the largest coefficient is x cube. So in x cube, and there is no x cube on the left side, so it's a 0. On the right side, when you multiply, distribute the first two factors, you need x cube, so the coefficient going to be a. And from the second one you don't get, but from third one you again get x cube term, so it's going to be c. So we can a plus c. But we don't know anything yet. We don't know a, we don't know c, so we cannot find anything. So let's go with the other coefficient, x squared. We don't have x squared term on this side as well, but do we get x squared term here? Yes. So we get x squared term when you multiply x squared with negative 1, so the coefficient going to be negative a, right? So it's going to be negative a, and then okay, yeah, so it's going to be negative a. And also in the second term you're going to get b, but we know that b equal 1, so it is a 1. So we can plug in whatever we know just to make the calculation easier. That's why we're going to use substitution first. So you get x squared, so you get a b, so but b equal 1. And then if you go to the next one, you can see that this is, I'm going to write this, the expansion of this one. The expansion of this one is x squared minus 2x plus 1. So let's think about how to get the x squared term. You get x squared term if you multiply cx with negative 2x. So cx with negative 2x, you get x squared terms. The coefficient is negative 2c. There's another way you get x squared term. If you multiply x squared with d, so you get a d, and so you get that. But there are 3 unknown here, so there's nothing you can do. So let's look at the other coefficient as well. So you write extra term until you find all the unknowns. So that we still have 3 unknown. That means we need 3 equations. So so what we can do is, actually you can go, because there are several ways to do the rest of the calculation. One calculation is you can find the coefficient of x, because there are several ways to get the coefficient of x, or you can always substitute 0. So substituting 0 is like another interesting step. So what we are not going to go for another more coefficient. What I'm going to do, I'm going to substitute we can substitute x equals 0. So you can always do that. X equals 0. Substituting x equals 0 means you coefficient you equate the constant term. So by x equals 0, what are you gonna get? So make sure, so this is like special substitution. You can substitute 0. So if you do that, you get 4 on this side. If you substitute 0, you're gonna get a times, if you plug in 0, x is gone, so you get negative 1, so it's a negative a. And from this next one you're going to get b, but b equals 1. If you plug in c, x equals 0, it's going to go, so you get d. If you plug in x equals negative 1, negative 1 squared 1, so you get a d. Now what we can do is, you can see, you can use these 2 formulas now. You can use these 2 to solve, because you can see that you have negative 1 plus d in both. So what we can do is you can subtract them. So if you subtract them, or you can substitute for -1 plus 1 plus d. So if you substitute for this term, you can substitute for that term in the top. So you're gonna get what do you get? You're gonna get 0 equal, you have -1 plus 1 plus d is 4, so it's a 4 minus 2c, and then this says that c equal 2. Once you find c equal 2, then you can go to the first equation. Then it says that a equal -c, that means -2, and then you can use any of those other equations. So you can produce the last one, which says that d equal 1. Okay, so we find all the coefficients. So you can see that you have to use a hybrid technique here, so to do this kind of problem. But yeah, it might take some time to do this kind of problem. Okay, so now let's finish the rest of the problem. So what happened? So we're gonna go back to the integral. So it is -2x plus 4 over x squared plus 1 x minus 1 squared dx. Unfortunately, you can see that all of the terms are non-zero. You don't get any zero term. That means you get all 4 terms. Let's start writing. A equal -2, so it is a -2 over x minus 1 dx, and then b equal 1, so it is 1 over x minus 2 squared dx, and then we have c equal 2 and d equal 1, so we have 2x plus 1 over x squared plus 1 dx, and then what you can do is the last one, you can split it into 2, and then so we can do these two. You're gonna get -2 ln x minus 1, and here we can use the power rule, so you can bring it to the top. So you're gonna go x minus 1 -1 over -1. And what we do here is we can split this into 2 integrals. So we have 2x over x squared plus 1 dx, and then plus 1 over x squared plus 1 dx. And we can do these two separately now. So so this we already know. So this is -2 ln x minus 1. This is -1 over x minus 1 plus so here we can use the 4 formulas. You can see that the top is the derivative of the bottom. That means this is simply log, and it's always positive, so we don't need the parenthesis, we don't need the absolute sign here because it's always positive, so you can the parenthesis here, and plus this is what, 1 over x squared plus 1. That's a tan inverse, so it's a tan inverse x over 1, so it's x plus c. So that is the answer to the problem. But you can see that this can be a little lengthy because of the expressions that we have. So we have 4 expressions and everyone was a non-zero. But this is how we're going to do the problem. And let's see, remember the last step here. So we split this into 2. So that's the only way to do this problem. So we have to split this into 2 integrals, and then we can integrate. Okay, so this is the end of the partial fraction method. So this is one of the very important techniques in integration. Okay, that's why this was lengthy. You can see that there are different type of problem that we need to consider. So I'm gonna put a star here because this is like a special type. There's a x squared plus 1 term, which is a irreducible term. So if you have a irreducible term, you have to have a special numerator. Numerator gonna be cx plus d in this case. Okay, it's not the repeating situation. Okay, so we're done with the section.